Okay, so this is the binomial probability distribution, and I'm doing this for one of my classes, but anyone could use it. So this comes out of a Cengage text, just to be clear, but I'm not monetizing this. I'm just using it for illustrative purposes. Binomial probability distribution is a function of the number of successes over the number of trials, factorial, times the number of successes, factorial, n minus x, and then the probability of the successes. So there's a lot of math here. Over 1 minus the probability raised to the power of the number of trials minus the number of successes. So a lot of math in that formula, but we have the benefits of modern technology. And really what a binomial probability distribution, the word binomial means two, is that we can have two probable outcomes in a sequence of events. So two probable outcomes, number of trials, and we can basically determine how likely we would have a success in a number of trials. So what do we exactly mean by that? Well, again, this is the number of experimental outcomes, going back to this formula. And this is the probability of a particular sequence happening. So you're multiplying the number of outcomes by the probability of a particular sequence. So for instance, if you were looking at a successful operation, two successful operations and one unsuccessful operation would be a sequence. So one successful and two unsuccessful in that sequence would be the way you would do it. But they would sort of equal the same thing anyway. I mean, the probability of going into an operation that has a 2/3 probability of success, whether you have success failure or failure success, you're going to find the same number anyway, just by way of logic. So here's the example we're going to look at. Martin's clothing store. Martin wants to determine the purchase decisions of the next 3 customers who went to the store. On the basis of his past experience, now this is his observation, the manager estimates the probability that any one customer will make a purchase is 30%, 0.3. What's the probability of 2 of the next 3 customers making the purchase? That's what he wants to know. The next 3 people, what's the probability of having 2 successes? So use S to denote the successes and F to denote failure. We are interested in experimental outcomes involving 2 successes and 3 trials. So we're going to do success, failure, which would be probability times 1 minus the probability. So 0.3 times 1 minus 0.3, we're going to have a probability of 0.063. So the probability of any of these sequences is going to be the same. And that's how you determine it. Okay, and anytime you have a binomial or bivariate or however you want to call it, the probability of having 2 different outcomes, and the probability of one or the other, that's how you would calculate it. Okay? Alright? So again, we plug this into a formula and we're going to come out with the probability of 2 successes, x. If we plug it into the formula, we're going to get a number which is 0.189, which is a lot of math and a lot of pain in the neck, basically, right? A real pain in the neck. But that's what it would look like on a tree diagram, which is always helpful to visualize. The first customer comes in, it's either a success or a failure. Then that leads to the next customer. That could be 2 successes or a success and a failure, or a failure and a success and a failure and a failure, and so on and so forth. So you have these experimental outcome sequences, and that's the value of x. 3 successes or no successes. So finally, the standard deviation and the variance and the mean, the variance and the standard deviation would be, the expected value of the mean would be 3 times 0.3, which is 0.9. The variance would be 0.9 times the opposite, and that's just a formula that came up that mathematicians have derived. And then we find the square root of the variance to get the standard deviation. So those would be the variance and the standard deviation, 0.79 of the expected value. Expected value being 3 successes which has a probability of 0.3. Right, the number times the probability. Okay, number times the probability, which is 0.9. Variance of 0.9 is 0.63. Standard deviation will be 0.79. So if we put 0.9 in the middle, we have one standard deviation, would be 0.79 either way, which means 66% of our probabilities should fall there. 0.9 plus 0.79 times 2, or 0.9 minus 0.79, 0.2. So it would be like approximately 1.6 plus 0.9, which is 2.5, or, subtract it would be, you'd apply the same rules as you would with, the standard normal distribution at any rate. Okay, so let's go back up, right? And here are the number of trials: 0, 1, 2, and 3. And you could do this with Excel now. So you have the number of trials, the probability of success, we just plugged it in. And then we just need to use the binomial distribution formula that we have on Excel. So in this case, I used A6, which is 0 trials, 0 successes, 1 success, 2 successes, 3 successes. And B2 and B3 I've anchored to the number of trials and the probability of success. And finally, I'm solving for when I put false in, I'm going to get the exact probability, the cumulative distribution function, which is one is the cumulative, one is the exact distribution function, right? The mass distribution function, or the this is cumulative, so and this is mass, which basically means, it's fancy terms for, this is exactly having 0, 1, 2, or 3 successes. So if I wanted 2 successes, there's an 18% probability, and that's my friend had an 18% probability. Or if I want 1 success, it's a 44% probability. If I want all 3, it would be a 0.027. So the more, in this case, you'd start to see how this gets distributed. And then this would be cumulative. This would just add the probabilities till we get to 1. Right, so we could see how it grows. So if I want to see the probability of 0 and 1, I could see it's going to be 3. I can kind of visualize that 34% of the time I'll get 0, and up to 78% of the time I'll get 1. Or if I ask the question, at least 1, I'll get that number. At least 2, I'll get that number. And I just repeated this, and you could do this at home and play around. Okay, and let me know if you want the spreadsheet by replying to me, if you're subscribing to my channel. And that's the probability of having 10 successes, or 10 trials. Notice as I get to 8, 9, 10, I mean, the probability of having 10 successes in a row, when I have a 30% probability, notice, is very small. And probability of none is very small, out of 10 trials, given a 30% probability. But somewhere in the middle, like 30%, given 30%, and 40%, it's going to be a higher probability. And I think I did a histogram. I thought I did. Let's see if I have it here. Bear with me. Let me do a quick histogram. So if we just go down here, insert, see which recommended chart, there you go. And there's a histogram. I won't put the title here, but notice how it distributes. So that's it. Any questions? Hopefully this helps. And I'm always here for questions. Thank you.